For each of the following functions, what happens if the input is doubled, multiplied by 10, or cut in half? There's three parts to this problem. Let's begin first with part A. Part A is the function y equals 1 divided by x to the fourth. Notice if the input were doubled, we would have an extra factor of 2 that we would place in for x, or we would end up with 1 over 2 raised to the fourth power, which if we raise 2 to the fourth power, we end up with 1 over 16. And 1 over 16 is equal to 0.0625. So if we doubled the input, we would end up multiplying the output by a factor of 1 over 16, or 0.0625. If we were to work with the same function and multiply the input by a factor of 10, then we would have an extra factor of 10 placed in for x. So we would end up with an extra factor of 1 over 10 raised to the fourth, which we could rewrite as 1 divided by 10,000, which if we rewrite that as a decimal would be 0.0001. So if the input were multiplied by a factor of 10, then we would have to multiply the output by a factor of 1 over 10,000, or 0.0001. Finally, if we were to cut in half our input, then we would have an extra factor of 0.5 that would go in to x. So we would end up with an extra factor of 1 divided by 0.5 raised to the fourth power, which we could rewrite that as 1 divided by 0.0625, which if we went ahead and divided that out, this would equal 16. So by cutting the input in half, we would have to multiply the output by a factor of 1 divided by 0.0625, or by a factor of 16. Now we can move on to part B. Now we're working with the function y equals 2 times x raised to the power of negative 3. It would be easier to work with this function if we rewrite this. Instead of using the negative exponent, we would rewrite it as a fraction, 2 divided by x raised to the third power. The negative exponent means we would move the factor of x cubed to the denominator. In this form, it's easier to see how a change in the input affects the output. So let's begin first with the input being doubled. We see then we would have to have an extra factor of 2 going in for x. So we would have an extra factor then of 1 over 2 cubed, which if we do 2 cubed is 8. So this would be 1 over 8, which this is equal to 0.125. So if the input is doubled, then the output would have to be multiplied by a factor of 1 over 8, or 0.125. Now if the input were multiplied by a factor of 10, then we would have an extra factor that we would have to multiply the output by, which would be 1 over 10 being raised to the third power, which we could rewrite this as 1 over 1000, which is also equal to 0.001. So if the input is multiplied by a factor of 10, then the output is multiplied by 1 over 1000, or 0.001. Finally, if the input were to be cut in half, then we would have to multiply the output by a factor of 1 divided by 0.5, and it would be cubed, which if we rewrote this, this is equal to 1 over 0.125. That would be 0.5 cubed, which if we rewrite that is equal to 8. So if the input is cut in half, then the output would have to be multiplied by 1 over 0.125 or by a factor of 8. Now let's conclude the problem with part C, the function t equals 1 divided by the square root of w. If we were to double the input, we would have an extra factor of 2 times the w, so we would have for the output an extra factor of 1 over the square root of 2 that we would need to multiply by the output. This is approximately 0.707 that we would have to multiply the output by. Now, if we were to multiply our input by a factor of 10, then we would have to multiply our output by a factor of 1 over the square root of 10. This is approximately 0.316. So by multiplying the input by a factor of 10, we would have to multiply the output by a factor of 1 over square root of 10, or by approximately 0.316. Finally, if we were to cut the input in half, then we would have to multiply the output by a factor of 1 over the square root of 0.5. This is approximately 1.414. So by cutting the input in half, the output would need to be multiplied by a factor of 1 divided by square root of 0.5, or by approximately 1.414. Thus, we've seen throughout this problem with 3 different functions how affecting the input affects the output.